All right, let's do a little review over chords and arcs. So remember, when you have a chord, you're talking about a line segment where its endpoints are on the circle. So that's a chord. And an arc is this curved part here. Right, so we're looking at that. Now there is an arc length, which we're going to do later, which is how many like meters or inches it would take to walk from here to here along the curved path. But an arc is also a certain number of degrees of a total. Remember, if you go all the way around, that's 360 degrees. So we have arc length and then the measure of an arc, and we're really just looking at the measure of an arc right now. So there are major arcs, which are going to be greater than 180, right? Those are greater than 180. Less than 180 if you're talking about a minor arc. And then a semicircle, well, that's just going halfway around. That's exactly equal to 180, right? Okay, so we can say the measure of arc AB. So instead of a line segment up there, it's a little curve thing. Look, it looks legit like an arc. So I don't know, arc AB, I don't know, that might look like 50 degrees, we'll say. So that's 50. Arc BC, I don't know, that maybe look like 100 degrees-ish. Okay. And then CD, I don't know, looks somewhere between 100, let's just say it was 70. Okay, so if we knew these three, like let's say these were the givens, could we find the measure of arc AD? And you're like, sure, right? If all of these add up, now this is not going to make sense based on my math. I didn't do a very good job of estimating these angles, but we have 50 and then we have 100 and then we have 70. Well, that's 220. That means there's 140 left. So even though the picture looks terrible, this guy has to be 140. It has to be because we know that there's 360 total. 50 plus 100 plus 70 plus 140 is 360. And obviously, arc AB, BC, and DC are really more than what I guessed because this guy is definitely less than 140. But it's okay, right? We can figure that one out based on knowing that all of them have to add up. Now, if I say the measure of arc ACB, well, see how this is the measure of arc AB and I go this way? If I say the measure of arc ACB, then I am going this way through it. So I have to go through C. And so like, if this is 50 and I went this way, well then this way would have to be 310, right? Going the short way is 50, going the long way, it has to be, you know, the difference, okay? All right, this is the theorem. Congruent chords, if and only if congruent arcs. So if you're given a picture like this and you are given that this chord AB and this chord CD are congruent, that's only true, like if and only if, right, a biconditional, if arc length AB and arc length CD are the same. So if these are both like, I don't know, 5 inches, if that's 5 inches and that's 5 inches, then if I know, let's say this arc length is 80 degrees, dude, this one has to be 80 degrees. Remember, this is a biconditional. Really, there should be like 2 arrows there. A biconditional. Congruent arcs mean congruent chords, and if you have congruent chords, then they for sure have congruent arcs. Okay? Central angle. This guy right here, which sometimes we use theta, sometimes we use x. That's our central angle, right? It's an angle coming from the center. It's formed by 2 different radiuses, or radii, sorry. And the central angle does in fact equal the measure of the arc. So if this is 90 degrees, this is 90 degrees. And again, I kind of showed you some examples, right? This is legit like a perpendicular, right? It's 90 degrees. Well, think about how much of the circle is that. Well, then that's got to be 90 degrees. That just makes sense. I'm going a quarter way around. So the arc is 90 and the angle is 90. Oh yeah, that makes sense that those 2 things are equal. And that's a little preview of future stuff. And again, if you looked at it here, if this angle in here is 135, well then this arc length here is also 135, okay? All right, a little more. All right, so far so good. I just noticed you might not even been able to see all that. That would have been terrible in that video, but hopefully you were listening to everything. Okay. And all right, so we also know that congruent chords are equidistant to the center and they're perpendicular. So if you have congruent chords, you also know they are the exact same distance to the center, and you know that those guys are perpendicular. Again, these are all just kind of facts you know. If this chord is congruent to this chord, anywhere on the circle, the distance to the center is the same and it's perpendicular. All right, now what about this picture? This is kind of a cool picture, right? So do you see how this length right here is the radius of the circle? But you know what? That one is too, which means those are congruent. What else do you know? You're like, well, what about isosceles triangle? Isn't it something about base angle theorem? Right? Remember, if that length and that length are the same, then that angle and that angle are the same. It's like the definition of isosceles, which means on this picture, you know that that angle and that angle have to be the same on a picture like that. So it's like a throwback to isosceles, but it's involving this. And then one more theorem, and there are a lot of them. If you are a diameter, meaning this guy, that's the diameter. If you are a diameter, then you for sure bisect this chord, which means you cut it in half, and you're perpendicular. And that's also a biconditional, right? That's a biconditional. So if you know, if you knew you had something like this, and you knew that was perpendicular, and you knew that was 4 inches, and you knew that was 4 inches, do you know that that bad boy is the diameter? Yes. If you know a chord bisects it and is a perpendicular, then you know that chord is the diameter. Just like up here, if you knew this was the diameter, then you know it bisected and was perpendicular. Excuse me. Okay, so we know diameters are perpendicular bisectors to chords. Okay, here are 3 kind of example problems that we can look at. All right, so let's look at this one. All right, so see how this chord and this chord are congruent? But if they're congruent, doesn't that arc and that arc also have to be the same, right? Congruent chords have congruent arcs. But if the arcs are congruent, I can set them equal to each other. And then I can solve. So I'm going to move the 10x over there and get 5x. I'm going to move the 20 over there and get 50. I'm going to get x equals 10. But if x equals 10, that means that's 130 degrees. Of course, that's 130 degrees. But if that's 130 degrees, what's this guy? You're like, well, 130 and 130 make 260. Well, that's got to be 100 degrees. But if that's 100 degrees, what's the central angle? Oh, yeah, right. The arc and the central angle are the same, so that must mean that central angle has to be exactly 100 degrees. So it's kind of how everything kind of filters together. This one, you're like, all right, I don't really know any. All of these are congruent, but I'm not really sure how that's important. But look, this arc plus this arc plus this arc, I'm going all the way around. So if I take that arc plus that arc plus that arc, I know they have to equal 360 because I'm going all the way around the circle. So an x and 2 x's, well, that's 4x. A 10 and a 30 make 40. Subtract 40 and get 320 and get x equals 80. Bingo, and I got it, right? X equals 80. X has to be 80, right? This is 80 degrees, 90 degrees, and 2 times 80 is 160, and that's 190 degrees. And again, if you add those 3 up, you get all the way around. All right, this one. Remember that and that are congruent because they're both a radius. But if those are congruent, these angles have to be congruent, which means that's x. And you're like, oh, yeah, check this out. I know there's 180 degrees in a triangle, so x plus 80 has to equal 180. So that's 2x equals 100, x equals 50. Okay, that's an example of how some of these chords and arc problems will go. Again, we have major arcs, minor arcs, and semicircles. Arc lengths can be going the short way or the long way. If you want them to go the long way, like the major arc, then you have to actually put that letter in there. And there's all sorts of theorems, right? Congruent chords have congruent arcs. Adding up all the arcs are 360. The central angle and the measure of the arc are the same. Hopefully this example is like at least these two are both good examples. Congruent chords are equidistant from the center, and also they're perpendicular. In this case, we end up getting a isosceles triangle in which we know the base angles are the same. And then the last one was kind of the fact that diameters are perpendicular bisectors of chords. Okay? All right, go ahead and start the problems.